Okay, so in this video we're actually going to be using the compound interest formula. In the last video we derived it, but in this video we're actually going to use the skill. Okay, so often what we need to do is we need to understand how our approach to a question changes depending on how often our interest is compounded. Okay, so these three questions I'm going to go through in this video are going to show us how to do that. Alright, so let's look at the start of the question. It says, find the amount that will be in the bank, so our final amount, after 6 years, our time period, if $2,000, that's our principal or our present value, is invested at 12% per annum. Alright, now I'm going to really highlight that. That is a 12% interest rate per year. Okay, now with our interest being compounded, and we have several different questions that we're actually going to go through, right? So, if we have our interest compounded yearly, that means once per year at the end of every year, our interest is compounded and then added back in. That's slightly different, say, to example, if our interest is compounded weekly or monthly. If our interest is compounded weekly, that means at the end of each week, our interest is calculated and put straight back into our account. And these can affect the amount that we end up with at the end of each year. Okay, so let's get stuck on having a go at calculating when our interest is compounded each year. First thing I always do is I write out my formula. A outside of P, 1 plus R to the power of N. Okay, so that's our formula that we established last video. And I like to write down, just on my left-hand side, all of my values that I have here from this particular question. So I know that my my principal amount is $2,000. Okay, I know that I have 12% per annum, so my interest rate is equal to 12% per year. We don't need to do anything with this because it is already compounded yearly. They're in the same unit, so it's important to pay attention to that. Okay, and the final thing is, don't forget, you need to heed my words when I say this. You must convert to a decimal. So 12% is just 0.12 as a decimal. The final thing that we need to do is we need to determine the number of times that it is compounded, right? Well, if it is compounded once per year for 6 years, it is just equal to 6 times that it's compounded. What we then do is we then go ahead and we plug everything into our formula. So our final amount is equal to 2,000 outside of replacing the P, outside of 1 plus our interest rate as a decimal, 0.12, that's just following that part of the formula, all to the power of N, which in this particular case is 6. Then you're going to do some simplification, right? You can simplify the inside of the bracket if you want to give you 1.12 all to the power of 6, or you can go from this step and start calculating. Okay, what you should end up with is, if we are going to 2 decimal places, and I'll tell you why we do 2 decimal places in just a moment, is 3947.65, and that's 2 dp. That's the final amount that we actually have in our account. Why did I go to 2 decimal places? Well, that's what our money is most often represented as. Okay, so that's why I went for the 2 decimal places. Again, you just need to be a little bit careful with this whenever you're doing it, right? Make sure you read the question. It might tell you to round to the nearest whole dollar. It all depends, okay? So that's fairly straightforward. So let's have a little bit of a look at how we approach a question when the interest is compounded quarterly. So when it's compounded quarterly, you need to just think about this for a moment. Our interest is compounded every 3 months, which means it's compounded 4 times per year. Okay, so just like last time, we write out our formula, A equals P outside of 1 plus R all to the power of N. Okay, we identify our principal. Well, our principal's still the same up here. It doesn't change. That's our money that we start off with. Okay, it's our principal investment. Okay, what will begin to change, though, is our interest rate. Now, remember, our interest rate is 12% per annum. That means per year, but we're not actually calculating our interest rate across the whole year here. We're actually calculating it in 3-month blocks, right? And so we need to take our year and we need to divide it by 4. Okay, I'm going to put a little arrow here just so you can remember something that I'm about to do. So we divide our interest rate here by 4 to give us, well, what's 12% divided by 4? Well, that will give us 3% across each quarter. Okay, right, making that a decimal just like before, it will give us 0.03 if we enter that in on the calculator. All right, now we need to remember that we have to adjust our compounding periods. Now remember, up in our initial question, it's in the bank for 6 years. However, because it's being compounded every quarter, that means it's being compounded 4 times throughout a year. So that means we need to multiply this number by 4. So I'm going to put a little up arrow here, right? If I decrease my interest rate by a factor of 4, that means I have to increase the number of compounding periods by the same factor. So our n is equal to 24. That's a little handy trick to help you remember if you're not quite sure of what's going on. All right, now it's the exact same process. We're going to plug everything in, okay, and we are just going to do the calculation. So A is equal to 2,000 outside of 1 plus 0.03 all to the power of 24. Okay, after you've done this calculation on your calculator, what you should end up with, and I'll do slightly off equal sign, what you should end up with is approximately 4,065.59 if we're going to 2 decimal places. You'll notice, interestingly, that this amount is slightly different to this amount. Okay, in fact, with a shorter compounding period, we actually got a little bit of extra money. Okay, so we can make a hypothesis now that if we shorten our compounding period even more, we should make even more money. So why don't we test that by, instead of compounding every quarter, all right, we shorten it down to be compounding every month. So if we have a look at that, I'll just switch out the sheets here. If we have a look at that, okay, same steps as before. All right, we write out our formula, A equals P outside of 1 plus R to the n. The reason why I do this is because it makes space in my brain when I move into a test, and I don't really have to think about it there on after. It just sort of comes as second nature to me. All right, I always write the principal out. This is, again, just to get confident. So we know it is 2,000 based off of everything else that we've done. Our interest rate is 12% per annum. Okay, now remember, this needs to be broken up across each month because we're compounding monthly. So if this is 12% per annum, I'm going to decrease it by a factor of 12, okay, to break it up into each month, right? So that means I end up with 1%. 12 divided by 12 will give me 1% per month, okay? Right, writing that as a decimal, I end up with 0.01. And again, now I need to adjust my number of compounding period. If it is in there for 6 years and we're compounding each month, that is 6 times 12 lots of our months, right? If this has gone down by a factor of 12, this must go up by a factor of 12 because we are increasing it by the same amount. So 6 times 12 gives us 72. Now, let's plug everything into the formula, okay? All right, so A is equal to our principal, 2,000, 1 plus our interest rate, 0.01. This is just using this formula here. All right, all to the power of our n, well, our number of compounding periods is 72. Okay, once we plug this into our calculator, we should come up with the number 4,094.20 going to 2 dp, which is interesting, okay? Because you'll notice on our previous couple of questions, we started off with initially 3,947, then 4,065, and then 4,094. So hypothetically, the smaller we make our increments for our compounding period, the more money we can sort of squeeze out of this. And that's because the interest is being calculated and put back into the account more often. So it's generating more interest faster. All right, it's just experiencing that exponential growth at a much faster rate. Okay, so ideally you want your accounts to be paying compound interest as often as possible, but most accounts in real life calculate your compound interest every month. Okay, in the next example, on the next video, we'll look at an example that can be affected by rounding severely. Okay, because we are essentially, if we create a rounding error, applying that same rounding error 72 times due to a power. All right, so we'll have a little bit of a look at that in the next video. Okay, thank you very much.